Hello everyone, I'm Yaojie from Ontario Tech University. Thank you for being here today, and I'm excited to present our work on StudyVR, a framework for streamlining VR user study design. So the overall goal of this framework is basically to simplify and streamline the process of designing, conducting, and managing user studies in VR. We aim to help researchers focus more on their scientific questions and hypotheses, rather than any of the technical and administrative tasks. Our framework could enhance the efficiency and accessibility of VR research, even for those with minimal programming experience. It provides a unified system for study design, data management, and VR deployment. And eventually, it can foster collaboration and accelerate innovation in VR user experience and perceptual studies. So while virtual reality technology has rapidly advanced, conducting user experience and perceptual studies in VR environments presents unique challenges. And these include the need for specialized equipment, complex programming tasks, managing large volumes of data, and ensuring compliance with data management plans and research ethics. And now, from the literature, we see several related works that address different aspects of these challenges in this area. While they offer decent experimental design features, but they either don't have the ability to display the questionnaires directly within the virtual environment, thus they cannot reduce the breaks in presence to eventually avoid bias, or they just don't have a centralized data system to basically simplify researchers' tasks. And additionally, most of these solutions require the researchers to have solid game programming skills to build up the system or just to load the stimulus. So to address these challenges, we propose our framework, StudyVR. It is a systematic framework designed to streamline the process of conducting and managing user studies in VR. And it has four main goals: automated administration, study design assistance, centralized study management, and easy VR deployment. Overall, it aims to reduce those barriers by abstracting the ways in which user studies are specified, stored, and synchronized. So to achieve these goals, we combine a widely adopted and validated experimental design with our framework that is designed for StudyVR. For the study design, our research methodology encapsulates a common pre-post intervention study style in user experience studies. This methodology can be broken down into several trials and stages from the start to the end of the study. First, we have the start phase, where the researchers launch the application and organize the configuration before asking the participants to put on a headset. In the next part, in the pre-study stage, participants will be given a tutorial of how to handle everything in VR, and demographics data are also collected at this stage. During the main stage, the stimulus will be presented, and the participants are able to finish the questionnaire directly in VR. And after all of these trials are completed, we enter the post-study phase, where the participants may be given a post-study feedback questionnaire, and also they are thanked for participation. Finally, the end stage will ask the participants to remove the VR headset, and one of our primary goals was to keep the participant in VR as much as possible during the study to basically reduce the breaks in presence and immersion. So now let's talk about the system design. The modular system allows the researchers to customize every single part as needed, but also it keeps the default options for the researchers who don't know much about how to program or just don't want to invest the time to build up the new systems. StudyVR doesn't require coding to create new trials or stimuli, but also retaining the ability to program trial mechanics if desired. So, starting from the networking-based database, our system first builds up the connection with the online database. And here, we chose to use Airtable and Google Drive as our database and cloud storage, just because they have well-structured APIs. The researchers would only need to interact with the web interface and just provide the system with the API keys. And the system could then sync with the online database to fetch study configurations, questionnaires, and all of the required assets. The researchers can easily configure and manage their studies, and this includes uploading study assets, setting up the trials, questionnaires, study parameters, and more. So the networking-based design of StudyVR leverages the power of Airtable and Google Drive to provide a flexible and user-friendly system for managing VR user studies. And with the benefit of its modular design, it's fairly easy to build up a local network system to connect with the original system, which makes the system even more capable for doing research. So in the middle part of our framework, as the core, we utilize Unity's powerful game engine capabilities to create the seamless and immersive VR experience. And here, we have the Mesh Sequence Player system and the Asset Bundle Helper system, both developed and ready to use. With the benefit of the modular design, it's pretty easy to integrate other plugins if needed. And now, let's talk about the study stage. Our research methodology uses the pre-post intervention design, which is highly versatile and can fit most of the user studies in VR. During this stage, the web view system in StudyVR can render any of the websites within the VR environment, and it works just like a normal browser, allowing the participants to interact with the questionnaire directly in VR. It also allows the researchers to use any preferred survey platform, and it works as easy as just to add the survey link to the database. So overall, the study stage of StudyVR is designed to maintain immersion and streamline the process of data collection and management. So, to validate the core idea of StudyVR and to identify any limitations or issues, we've designed a simple user study to be performed by StudyVR to invest uncanny valley effect, basically as a proof of concept case study. For the metrics of study, we used modified Godspeed indices for humanness, eeriness, likability scale, and preference scale with the independent variables such as asset type and motion type. And in our case study, there are two types of assets: volumetric video and a character animated by iClone. In StudyVR, there's a built-in Mesh Sequence Player to play the volumetric video, but for the animations created with iClone, they require the iClone Unity plugin to play. And this also can test whether or not StudyVR can easily handle the inclusion or integration of any other plugins when needed. So after successfully integrating the iClone Unity plugin, we used the Asset Bundle Helper tool to create a dedicated Unity asset bundle, which then we put them into the Google Drive for storage. This process is quite straightforward and only requires basic Unity skills to integrate the necessary external plugins. After building up the StudyVR to our headset, we added the asset links and Google Form links just through the website interface provided by Airtable and Google Drive. When StudyVR is launched from the headset, it auto-detects each study listed in the database, allowing the researchers to select the desired study. And after preloading all of the assets, participants can seamlessly complete the entire study. And regardless of whether we use Google Forms, Microsoft Forms, or any other survey platform, StudyVR will render it within the VR environment for participants to interact with. So while developing this proof of concept user study, we found that the system is capable of providing a rich sampling of possible user studies with its methodology and abstractions. The use of integrated forms enabled us to create any forms of questionnaire for different studies or per trial user feedback. The use of Unity asset bundles as the primary means to store assets enables a much richer set of possible studies than just simple stimulus presentation. And that's because an asset bundle can include the entire scene and all the prefabs. And this provides the researchers the ability to go far beyond the provided functionality and create highly complex and interactive trials if desired. For limitations and future directions, we aim to extend the capabilities of StudyVR, such as the completion of a web-based design interface and exploring additional use cases to further validate the system. While this framework requires decent network environment and fast processing speed for real-time loading, as a limitation, it doesn't perform well when the stimulus has super high fidelity and a huge file size. One of the future directions from our plan is to build up a streaming connection within the local network to further extend the capability of the StudyVR framework. Okay, so now let's watch the demo videos. And due to the time constraints, the videos have been sped up. So once the user clicks the start button, the system will begin preloading the stimuli. And after the user finishes the pre-study survey, the stimuli will show up and they're allowed to do the questionnaire while in a VR environment. And for this one, it shows the capability of conducting a user study for comparison by using another survey platform. Alright, so this is our presentation. Thanks for listening.